Hello friends, today I'll be talking about SPRT, Sequential Probability Ratio Test. It's a statistical testing technique where you don't consider the entire sample at a time but go on collecting the sample one by one till you reach the decision. So to start with, I have talked about statistical testing in an early episode. So we fix null hypothesis H0, alternative hypothesis H1. We fix the test statistics, then we calculate the critical region or find the p-value. If p-value is less than 0.05, we reject null hypothesis. Otherwise, we accept null hypothesis. So that's the general statistical testing. In sequential testing also, we start with a null hypothesis H0, so theta equal to theta 0. So average height of population in Kolkata is theta 0. So we fix theta equal to theta 0 and an alternative hypothesis theta equal to theta 1. Then our test statistic is the log likelihood ratio or the cumulative log likelihood ratio, whatever you want. So we need to talk about the log likelihood ratio a bit. Suppose the data is represented by X, the random variable. It can be univariate, it can be multivariate. And we know its distribution function, which is f0x under h0 and f1x under h1. Now whether you can use empirical distribution, that I don't know. I think we need to see, but you have the distributions in your hand, f0x and f1x. Then the log likelihood statistics lambda x is defined by f1x by f0x, where x is the observed data. So to construct the test statistics, so we are going on sampling x1, x2, x3 sequentially. The test statistics SI is defined as, to start with, S0 equal to 0 and SI equal to SI minus 1 plus log lambda XI. So it's cumulative log likelihood ratio. Now we need to fix two bounds. So we have the values of alpha and beta, the type 1 error probability, the type 2 error probability, and we define the two bounds as a equal to log beta by 1 minus alpha and b equal to log 1 minus beta by alpha. So these are two bounds we need in SPRT, and we can think out that a less than 0 less than b, and everything is finite. So we need to do some mathematics to deduce it. It's not easy. So what is the sequential testing technique? We continue sampling as long as the cumulative log likelihood ratio SI falls between A and B. Whenever it goes below A, we accept H0, and whenever it goes above B, we accept H1 and stop sampling. That is the end of a sequential sampling. We go on sampling until we reach a decision to accept H0 or to reject H0. So that's the sequential testing. So in the picture we have two bounds, A and B. We accept H0 if the sample path goes below the bound. We accept H1 or we reject H0 if sample path goes above the bound. And we have cumulative log likelihood ratio in the y-axis. Cumulative is missing here. So that's the technique. A bit of history. The sequential probability ratio test SPRT is a specific sequential hypothesis test. It is developed by Abraham Wald in the first half of 1900 and later proven to be optimal by Wald and Jacob Wolfowitz. So some of my story about SPRT in a Benares Hindu University conference, Professor J.K. Ghosh talked to me about SPRT, about his field experiences with SPRT. He said that from his field experience, the sampling didn't continue more than 2 or 3 terms. So I thought about it words, and I think he was looking for the betterment of bounds of in a paper by his friend Professor R.A. Wiseman on exponential bounds. So we have the paper here. It's a paper by R.A. Wiseman, exponentially bounded stopping time of the sequential t-test, and Professor Ghosh thought that this could be heavily improved. The exponential bounds could be heavily improved. I mean, that's my idea. I'll stop here. Thank you.